Hey everybody, welcome to a little Sideline Space Engineers where I want to dig down into a topic if you don't mind. I won't bore you too long, so let's get started. What I want to go over is a quote-unquote infinite drill. This is a system that is drawing inspiration from a find on the workshop, Swag Tommy 1098's Infinite Drill Blueprint. I will include a link in the description if you want to go have a look yourself, and I do recommend it. It is a really nice setup. It was such a good setup that I immediately want to break it down and figure out how to make one myself. For a couple of reasons. One, the blueprint does have a lot more attached to it than just the drill, as it comes with a lot of its own built-in infrastructure, which was kind of inconvenient and wouldn't really slot well into the base I was working on. But secondly, I also wanted to figure out because it's really cool and frankly ingenious solution. So with that said, let's tunnel into the topic. The basic concept is that of an inchworm. Unlike other infinite drills, which usually add to the drill head in an ever-lengthening shaft, this one uses a single piston. In its operation, the piston moves forward, welding its projected rail as it goes until it reaches its max length. There, it grabs onto a waiting rotor head and then immediately disconnects from the backside and retracts. Once retracted, the rear rotor then grabs yet another waiting rotor head, releases the forward one, and begins the cycle again. Now that we have an idea of what we're making and how the system works, let's get started with the first part, the rail. This part may seem to be the most onerous, but you only have to do it once. What we need is to make a rail that will be the spine for the drill. This really is the most critical part, but it's also one of the most basics. So for this first part, you kind of have to think about how you like to play. And everyone's got their own style, and more power to you. You play the game the way you want to play it. And what I'm talking about is whether or not you want to do this part in creative mode or not. So right now you can see I've got creative mode enabled. What that course boils down to, as everyone who's played the game knows, is that when you place a block, so let me get a block here aligned, and I push it into the grid, it just creates the block and leaves it there. Now, the thing about doing it, of course, in creative is that it doesn't use any resources. So depending on how you're playing, you might feel that this is cheating. It's not really, because this is not a permanent fixture. This is simply something that you can get a blueprint from. So if you're feeling that, this is a cheaty thing going into creative for this step, we're not, because we're not using any extra resources. Now, of course, this also doesn't mean that everyone can go into creative. If you can't go into creative, or you just don't want to, it doesn't change that of how we're going to build this. All right, to start off with, I'm going to put on my first straight conveyor. I'm going to follow that up with a second conveyor. Let's get you placed. There we go. Now I can make a decision here on whether I want to have 2 conveyors or 3 conveyors in this section, because these guys are going to be followed up with a conveyor T. Now you can use either one. It really will have no overall impact in the efficiency or the workings of the drill. It just means you're going to have different spacing. Whether it travels 7.5 meters actually before it switches over, again referencing back to the diagram, or whether it goes 10 meters, that extra 2.5 meters, it really won't make that much of a difference. I kind of prefer using the 2-to-1 ratio. So that's what I'm going to do here, is put in 2 straights followed by a single T followed by 2 more straights. And I'm going to do this for probably a good 100 some odd or more blocks. The longer you can make this, the less you need to actually monitor what's happening at the end here. So let me get this thing built out and we'll come right back. Okay, so I've got the conveyor rail built. It's about 120 blocks from this end down to that end. And that should be plenty long enough, at least for now. So the next thing we want to do now is we're going to need to add rotor heads to these T-junctions. So let's grab our advanced rotor head, and this is really important if you want to be able to draw materials from this. So we're going to go with our advanced rotor part. Now, really important, on the rotor part, there is this line right there. That line is 0. So 0 is not determined by the rotor, it's determined by this rotor head of where that line is pointing. And it's really critical that we make sure that all of these rotor heads that we're going to place down are in fact pointing in the same direction, preferably forward with that 0 line. So I'm going to put one down there, and I should be able to now. So if we just do a quick flip around here, make sure that we're facing it forward, we can put a next one there. I'm going to go down the line here, making sure, again, that line is facing forward, which, you know, might be depending on the neck, but really super critical. And that is the last one. There we go. All right, so we have our rail here. And again, you can see I'm just going to kind of run down the line here, make sure that I haven't messed any up like this one here. So let's do a quick, careful grind down. And let's put that in the right place. Again, I want to make sure that line, so that line is facing forward. Let's keep moving down here. Space. All right, now that we have that all built up, and if we take a look here, you'll notice that on this end, it starts with a straight conveyor. But if we go all the way down to the other end, it ends in one of our T-pieces. It's not super critical. It just might make life a little easier when we're kind of setting up projectors and the like. All right, so now that we've got this built, we're going to want to take a blueprint of it. So Control B, and doesn't matter what name it is there. I don't need to name the grid or anything. I just need to make sure it has a valid name, unwelded rail, for our blueprint library. All right. There you go. Have a look here. We can see that I now have this rail saved as a blueprint, which means I no longer need this, so I can fly all the way down to the other end and start grinding it all away. So, let's start grinding. And that is the last of it. Okay, so let's look what we're going to actually do with this now that we've got it all gone. So I've already pre-set up myself a little base here with a cargo container, a assembler, a refinery. I have a little med bay here just to kind of keep myself supplied. I've got an O2 H2 generator on here. I'm running a small reactor with a battery, and I've got a projector. I've got this trench here for where I'm going to be placing the drill. So, like I said, the thing that kind of prompted me to figure this drill out on my own was that if I'm going to be doing this kind of massive amount of drilling, I'm probably already going to be having a base set up, infrastructure all ready to go. Now, I've just set this up for the demonstration here, just because, making sure that you can see that it could be anything. Now, I've got a little bit of supplies in there just so I can do this in vanilla. If I was in creative, of course, I wouldn't need any of this, but because I want to do this in vanilla, non-creative anyway, not necessarily, well, it's vanilla, or at least certainly non-creative, I wanted to have this in here. Now, you don't really have to worry about whether or not you've got enough supply, and this is the same thing with the infinite drill from the workshop, is that it'll actually be self-feeding itself, and that's why I have this cargo container. Because what I'm going to be doing is I'm going to be drilling a tunnel essentially through this cliff face here. Now this could be, say I want to go to a giant underground bunker. Maybe I'm going to dig it out and hollow it out for a bunker. Maybe it's literally a tunnel to cut through this mountain. Either way, that's the cliff face I'm going to go into. Of course, that means we're going to be digging into stone. So I need to have a cargo container. And of course, stone gets turned into iron, it gets turned into nickel, and it gets turned into silica. And for most of what we're going to be doing here, except for a little bit at the initial setup where we might need some metal grids, we really don't need anything more than just nickel and iron. Okay, so with that being said, so again, we have our base, we have a conveyor running here, I have an open, ready to go slot right here. Let's actually get started in building this out. So let me get over here to my projector. I'm gonna turn my projector back on, I'm gonna go into my blueprints here, and I'm gonna go find my unwelded rail. There we go. Okay, if we look here, we can see that it's not exactly lined up in any way, shape, or form. This is why I really like using Build Vision, because it makes working with projectors a lot easier. So what I'm going to do here is kind of get it so I can see, and we are going to roll it. There we go. We're going to yaw it. Nope. Pitch. Yep. Okay. And let's slide it forward a bit. And I'm going to start it right there. Okay. Whoop. Turn my... So again, it doesn't, it wasn't super critical that I have it perfectly lining up, because we can just set the blueprint to wherever we want it to be. But this is where I want to start with. Now, I'm going to need to pre-weld some of these blocks up, like this guy right here. The rotor head here, this conveyor, this conveyor, and of course that rotor head there. Okay, so now that we got these guys welded up, I'm not going to worry about welding up these parts of the rails here, mostly because I'm going to use it for testing the rest of the system. Just to kind of make sure before we get into the cliff face that, things are working here. So with the piston head or rotor part sitting there, we do need to get a rotor to attach to it. Now, we can't just, flip one over here and hope it lines up, because if I try to build this guy, it comes with a rotor head attached to it or a rotor part attached to it, and it's going to be a real difficult time of getting it to sit in place. Instead, we can just basically cheese it just a tiny little bit. So what I'm going to do here is I'm going to put a piston right there. On the top of the piston, I'm going to add a couple of blocks just so it extends out that far, and I'm going to drop another block in there. Let me get this guy quickly welded up. And there we go. All right, let's lift the piston up. So I'm just going to reverse it, let it go up. And that's what that block there is for, is to put our rotor on there. So I'm going to, again, making sure I'm using an advanced rotor. I'm going to rotate it around so it's 0 degrees is also facing forward. Let's make sure we have some steel plate on us. There we go. And I'm going to put this guy right there. I'm going to get rid of the rotor part on it. And then hopefully when I lower this down, and there it lowers down into place. Perfect. That's all I needed to do. I'm going to now attach it. And you can see it's now attached to that rotor head. We can get rid of all the rest of this stuff now. So let's grind this stuff down. I'm going to throw the parts into the rotor. And get rid of that piston. All right, we got the rotor in place. If we look at its angle here, you can see it is essentially at 0 degrees. I want to make sure it stays at 0. So I'm going to set my lower limit to 0 degrees, and I'm going to set my upper limit to 0 degrees. And you can see that it is now snapped into place. I'm also going to crank up my braking torque. because I don't want this thing to have any kind of be able to wiggle at all at any point in time. So we're going to set our braking torque to 1,000 meganewtons, and there we go. We've got our first rotor in place. Now on top of this rotor, I'm going to add a conveyor junction. So I'll put a conveyor in again, make sure I have the parts. And let's pop this on top here, just like that. All right, to this guy, I'm going to grab myself another square piston, and again, make sure I have my pieces. There we go. And I'm going to attach right like that. I just want to have that panel somewhat accessible for attaching the rotor. All right, or moving the piston. Okay, so now I want to grab another rotor. Now, you'll see that, of course, I don't want to put it there because that's going to sit too high, so I'm going to grab myself another conveyor junction. Again, making sure I have the parts for it. There we go. All right, so I'm going to put another conveyor junction right there. With that conveyor junction in place here, I could try to place my rotor down like that, but that's going to come with a bit of a problem in that it's got a rotor head sitting there already. So before I place the second rotor, I'm going to weld up my piston here, and I'm going to give it a bit of an extension. So we're just going to hit our reverse button again, and I'm going to extend it out beyond the rotor head here. So now when I grab this rotor, and again, I just want to make sure that it's aligned the same way, I can get rid of that rotor head now and reverse my piston back into place. Now the nice thing is that, oh no, it's gonna collide. Look at them, they're gonna collide any second. It's like Austin Powers and the guy in the ice. The nice thing about rotor heads is that rotors pass right through. No collision whatsoever between these two parts. So that I can now weld this guy up and all the other pieces. So let me just get everything welded up here now. And there we go. All right, so this rotor is attached. This rotor is not attached. That's fine. We don't want it attached right now. So this is your basic setup for the drill. Whether you're doing this as a small drill, big drill, maybe you want to put some welders on the end, whatever you want to do, everything from here on is optional, as long as we have this core, inchworm here, because we can add anything else that we want to it, including things like our drill heads. There is one more part we're going to want to add. So let me just quickly duck underneath here, and that's going to be a welder right next to the drill head. So I'm going to put it right next to this rotor, and there we go. All right, so that's all welded up. I'm not going to turn it on just yet. What I want to do first is, remember how I said it was so important that we had that one little line that was facing forward. So before I do anything else, I'm going to make sure that everything is in fact aligned. So I'm going to go to this rotor here. I'm not going to set anything yet on it. All I want to do is do the attach. And if everything's set up, it should be pretty much at 0 degrees, which is exactly what I want. So now when I do the limits, so again, I'm going to do 0 degrees and 0 degrees. And again, crank up my braking torque. All the way down the line, I'm not going to have anything doing strange, because if that line was, say, pointing off in that direction, as soon as this rotor attached, the whole thing would try to twist to realign to that line that is on that rotor head, and that's the line you can see right there. So we can now detach this head. Everything's perfectly fine. There's a little bit of kind of compression in there because it's not exactly 2.5 or 5 meters between that, but it is close enough for our purposes. Okay, so let's test out the basic operation before we automate it, and that's again why I didn't weld these guys up, because I'm going to use this welder here and kind of make sure that we have everything attaching its proper way. So I'm going to turn the welder on, and I'm going to slowly start moving this piston forward. A little faster than it would be for drill speed. Now, you'll notice that it's not drilling anything. And if we look in our inventory, it's probably because we don't have the right materials. Yeah, I've got a lot of food and stuff like that, but yeah, there's not really the right amount of steel plates. So it's trying to pull the parts, but it doesn't have the right parts. What we need to do is we need to set up our assembler now to make sure that those parts are always going to be available. So there's a couple of different ways that we can do this. You can use a programming block and run the Izzy's Inventory Manager script and set up an LCD for auto crafting. You can use the kind of Izzy's replacement, the GOAT inventory sorter. Yeah, it's called the GOAT. You can use the quota mod, so the assembler quota mod, which I don't have installed. Or you can actually do it based entirely on the kind of vanilla production here. So we can set up a production queue and have it automatically repeat itself. So I'm going to turn the assembler off for a quick sec, just so it doesn't do anything before I'm ready. And what I'm going to do here is go find my conveyors, so my armored conveyor. There we go. So I'm going to grab my armored conveyor. We're going to call up 1, 2. You can see it's putting the parts in the queue. And then I'm going to go find my rotor part. So again, I want the advanced rotor part, and I'm going to have one of those ready to go as well. And I'm going to turn on my enable and repeat mode. So when I turn this back on, it's just going to start continually producing those items. All right, with the assembler doing its job, we can see that it is finished welding that piece up there. So I'm going to now creep this piston forward at basically the speed. Well, let's just get it past there a little bit. So we're just going to let it creep forward here, and it should now build the rest of the stuff as we move forward. Now we do want to have a bit of inventory kind of built up, so that by the time it gets to the rotor head, it doesn't have a delay, because, you know, the timing's a little bit tight here. If the rotor moves over to where the rotor head has to weld in before it has a chance to weld in, it could cause a problem. But if it does, it's a pretty easy fix. And there we go. Rotor head is getting welded in as long as it gets started first. And our piston will go. Now I am going to start the piston right where that rotor lines up, and that should be around 7.5 total maximum distance. So I'm going to reduce this down to 7.5, maybe actually even 7.4. You can hear it already welding the next section, and there we go. So our piston is now properly lined up with the next rotor head. Now this is why it's really important that we make sure that these lines are in the right direction, so that when I attach this guy, crossing my fingers, nothing weird happens. There was a little bit of a shift as it grabbed on, but the angles line up. So remember, 0 is where that is. That's where the rotor is going to orient itself. It's going to orient itself along that line. So we want to make sure that we built our, why it's so critical that we built them the way we did on our rail. All right, so next thing we do is we're going to need to detach this rotor. So we're going to detach it, and we're going to just collapse the piston. So down it goes. And when it hits 0, it should be ready right over this next rotor head. And there you can see that it's now lined up. I can attach the new rotor head. So let's make sure that it's attached. Not the piston. I want to be careful. There we go. So now the piston's attached. And we can now detach this one again and start the cycle over. All right, so that's our basic cycle. Extend, attach, detach, collapse, attach, detach. Yeah, we want that to be automated, and we're going to do that with a couple of event controllers. So I'm going to go grab an event controller here, and I'm just going to put them over in the corner. So I'm going to make one of these guys here. I'm going to leave it as red that I've been building the kind of rusty base out of. But I'm going to have the other one here being kind of this lime green. And I want to separate them because it just makes it more easier to kind of keep my head straight, which for what each event controller is doing. So let me get these guys quickly built up. Okay, so those guys are built up. We're going to need to do some naming here, and this is going to be really make our lives easier. So this will be drill, back rotor. This one is going to be drill front rotor. We are, of course, going to need the piston to have a new name. And this is going to be drill piston. All right, so there we go. So this first event controller is going to be in charge of what to do when the piston is at its full extension. So that means what is it going to do? And if I hit reverse here, when it's all the way out to the end there. Let me just back this guy up, make sure that nothing weird happens. All right. So what we want is on this, which will be the, let's call this the drill retract event. It's going to be based on the piston percentage. Which piston? Well, the drill piston, of course. So we're going to set it drill piston. Yes, it is in fact a subgrid because it's sitting on the end of a rotor. And what its actions are going to be, and the really important that we set this up in the right order. So first action is the drill front rotor needs to grab onto that rotor head that it's going to be sitting next to. The second action is going to be the back rotor detaches from that cylinder, from that rotor head. And then we can set our speed. So I'm going to set a velocity. I'm not going to do a set and move. We could do 0 set and move, but just to make sure that everything kind of works right, we're going to use our set velocity. And I'm going to have this set to -1. There's no sense mucking about. All right, and then we can hit confirm. Now, if we look at the percentage rating on that position, we can see that the threshold is currently at 0%. So I want it to be equal or greater than 100%. But it's only going out to 7.4 meters. How will it ever get to 100% of 10 meters? Well, that's the reason why I'm using percentages and using set velocity. When it says at 100%, because right now it's at 0%, what it's actually meaning is at whatever length it's allowed to go, whether it's 1 meter, 2 meters, 10 meters, or in my case, 7.4 meters, what that means is that it's going to be at 100% of its allowable distance. So that's why I want these guys to register on that. Okay, so our next one here, so that's when the drill is at 100%. It's going to detach this. It's going to, attach, detach, and then collapse and work its way forward. We'll see that in action in a minute here. All right, for this one, we want to set this one up. Again, it's going to be based on piston percentage. The drill piston, so we're going to add that to the list. I'm going to have it equal and less than 0%, so it's currently at 0% here. We're going to select our actions, and it's going to be the opposite of what it's doing. So this is now retracting itself, which means the back rotor then is going to need to attach itself. The front rotor is going to detach, and the order I'm doing it is important. We want boom boom. Now they're happening almost simultaneously, but there is a slight difference in when the operations carry out. And then I can set my piston to its new velocity, which in this case I'll set it to 0.1. Now when I'm actually drilling, that'll probably be slower, but at least for the demonstration we can include it at that distance. All right, I'm going to test it all out here. So I'm going to do it reverse. So I'm going to do is attach this rotor head. I'm going to detach this one here. And I'm going to extend my piston to 100%, and we should see some things happen. All right, so let's extend the piston. So it's kind of going, a little bit backward at the moment, but, it'll do what I need it to do. So I'm going to reverse. Now remember, when it gets to 100%, it should keep this one unattached, and it should immediately retract itself. And there it goes. It's automatically retracting itself. Now we want to watch what happens when it gets to 0. It locks on, detaches, and starts extending, and away it goes. Now we can just sit here, wait for it to weld its next parts up, and we'll see what happens next. All right, everything's welded up. It's coming into its new position here. Let's move back where we can see. And what we should see is attach, detach, and collapse. And there it goes. Once more into the cycle. And boom. Perfect. Okay, I'm going to turn the drill piston off for a quick sec here. I don't want to go in too much further, at least just not yet. There's one more thing I want to add to this before I kind of look at actually setting up my drill head. And that is the kind of end case scenario of what happens when it runs into the end of the blueprint. So I'm going to turn off my projector, and that's going to say basically that, there's no more blueprint. So it would basically fall off, and we don't want it falling off. So it's come to the end of its rope. How do we prevent disaster? Well, this is where we're going to grab ourselves a sensor. So I'm going to put a new sensor, and let's make this the same color. And I'm going to use the fancy... Okay, so in the sensor, and I want to make sure I got it facing the right way, we're set our extents, so we're going to collapse all of the extents to their minimum. So all the way down to there, except the bottom extend. I'm going to leave this one at about 2 meters. So if we turn on view in HUD and we go to our show sensor field range, we can see that I've got a field that's basically pointing straight down, just this little kind of rod. It's very narrow. It only extends onto the next block. It doesn't go any past there. So what it's doing is it's looking at the next block after the last one that it's locked onto. All right, it's currently red because we need to do a little bit more setup on it. So I wanted to basically detect everything. So any floating objects, small ships, large ships, stations, subgrids. There's the sound. Sure, why not asteroids? Basically, detect everything, and we can see that it's now showing green. So when it's green, that's its number 1 slot. What I want it to do is when it's in the green, I want you to take our piston and turn it on. When it's in the red, though, which is position number 2, I want it to turn off the piston. Because remember, the entire automation system is being driven by the position or the percentage position of the piston here. So if the piston stops moving, it will never trigger the 2 conditions. So let's do a quick test here. I'm going to turn the piston on now. We're going to follow it forward. Remember, there's nothing for it to weld. There's nothing else after there. If it goes through the hits 100%, it's going to detach, have nothing to attach to. It's going to be a mess, and it's just going to fall off its rail. But piston sensor passes that range. Piston shuts down. We're back in business. So we can now carry on again. Okay, that is the operation of the basic piston setup. Now, let's actually look at what we can do with it. So like I say, I want to start doing some drilling here. So I'm going to set up now a proper drilling scenario. And that is the last. All right, so let's do some quick groups here. So all of these drills, so I'm going to select all of these drills here, and we're going to name these drills because that's original. I'm going to rename this rotor to drill head rotor, like so. And I think that's pretty much everything ready to go. Now, I think that I'm out of materials again, but that's okay. We had enough to get to this point here. So I'm going to turn all of my drills on, but we're going to set this control panel up now. So the first one here is going to be the drill piston. So let's find our drill piston. I want to be able to turn that on and off manually. Next one is going to be the rotor, drill head rotor. And again, I want to be able to turn that one on and off. And then in our groups here, we want to have our drill themselves. All right, so we can turn our drills on. I'm going to look at where things are shaking. Let's get a little bit of bounce to it. So I'm going to turn on the inertial tensor. Yeah, it seems to have stabilized it quite a bit. That's good. Let's turn on our rotor. Now the rotor, it doesn't actually have a velocity yet, so we're going to have to set that. So again, let's make sure it's turned on. So we don't want to have too fast a velocity that the drill heads can't keep up, but not so slow that the pistons end up keep pushing it in, that it doesn't clear enough material. So let's go with something like, I don't know, let's go, I like clockwise. So negative 0.5. Now remember how we said we're going to have to change our speed. Now that we've got a drill head in the way, we are going to need to change this speed here to something much slower. So we're going to set our velocity now for proper drilling, which is going to be 0.02. Just inch it along. I don't want anything getting too rambunctious and causing the thing to explode on its own. I think I can go faster here. Actually take it up to something like, the piston's slow enough, that should be fine. Now of course I am now should be bringing stone in, and if we look in our refinery, we can see that it's slowly gathering up the stone. Now of course it's not really going to keep up because the piston's not moving, so we are going to have to get that piston moving. I'm going to turn my projector on first because we want this thing to actually start operating. So let's turn our projector back on. The welder's not quite in range yet, that's okay. And let's start drilling. So I'm going to set its actual speed here. So again, it's going to be 0.02. So I'm holding down the control key and using the mouse wheel to get that. Let's make sure our vent controllers are turned back on. Let's see how the rotors or the drills are doing. Make sure they're not impacting with the voxel. They're just clearing the voxel. Otherwise, I might have to slow the piston down, but so far, so good. All right, we should see a link up momentarily. All right, and should be locking up any sec. There it goes. Let's see if our new speed kicks in. And, yep. Go forward. All right, let's just make sure we get the next piece welded into place. At some point in time, we are going to get too much stone. Probably not that far in the future. So I want to put another safety. So not just the what happens when we run to the end here, but what happens when our cargo container gets too full. So I'm going to set up another event controller. So let's get this event controller in. And on this event controller, it's going to be based on cargo filled. So essentially, when our industrial or large industrial cargo container gets full, so it's equal or greater than, let's say, 92%, I want my drills to turn on clearing mode. Because again, the whole point is just for me to put a hole in the side of the mountain. I'm gathering the stone and whatnot temporarily because I need the material to build the rail, but if it has a full load, I don't need to gather that stone anymore. So we're going to put that one there like so. Now, what happens if the cargo container gets empty? So I'm going to use another event controller. And same thing before, I'm going to set this, guys, it's cargo filled. This is going to be equal or less than. Now it's going to have stuff in there, so I don't want to go all the way down to 0. I figure if it gets below 30%, then I want it to do its action, which is going to be, again, in our drills, turning terrain clearing mode off. Let's take a quick look at my container. Yeah, see, it already got relatively full because we've got like 1,000,000 stone. The safety's already kicked in. That's how fast it can go. And in fact, it is now in terrain clearing mode. Okay, so I've left the drill running for a little while, and you can see that it is, in fact, happily moving along. If we look at the pattern of the borehole here as well, you can see that it kind of has this ribbing going on. So you can see there's a rib right here and a rib right there. What that is telling me is that the drill is in fact switching from land clearing mode to non-land clearing mode. In fact, it is just switched back to land clearing mode. Some other things that while I let it run that might help you just have a more efficient system is maybe consider adding a stone sorter to your setup, or sorry, I should say a gravel sorter to your setup, just to make sure that we don't have all of this waste material clogging up our cargo storage, because at some point it will overfill, which will stop the drill's movement. Now, the drill will not fall off, it will not break, it will just stop moving. So we have that safety in place. So the gravel will accomplish nothing but delaying our progress. The other thing I'd recommend you use to make your system more efficient is the production quota mod by Drago Corvan. It is a lovely quality of life mod, and what that allows us to do is to go into the assembler's control panel and actually set up some small basic keep in inventory. So you can see I'm keeping constantly 25 construction components, 50 interior plates, 150 steel plates, 50 small steel tubes, and it really is easy to set up. All you have to do is select the item you want to make sure you keep some of. So let's keep 10 girders here in case I want to do some windows. So I can type in 10. In fact, I can apply it to multiple objects. So if I select 10, I hit set. It's now going to make sure that I always in my inventory. You occasionally may have to go into your assembler to make sure your inventory is not getting too full. So it's having some trouble building some stuff because it's glutted with silicon. So we can see that it is stopped. Again, it's not necessarily a panic moment, because if it cannot weld, because I don't have any nickel iron in there, it just will stop. And in fact, it's already stopped, I believe. So if we look at our piston here, maybe it's not quite, yeah. So the piston has stopped. And that's because it doesn't have the parts necessary to build the next piece. To get it going again, we are going to have to go to the assembler's panel. So we go to our assembler, bring up our large cargo container, and just move the excess out. And there we go, it starts grabbing in the nickel and immediately begins our production again. And you can see right down at the bottom here, it's good to go. I've turned off any repeat mode, so this is all being handled just by the quality of life mod. And it adds it in as it uses. So if it uses 24 plates or 31 plates, it just rebuilds those and carries on its merry little way. If we run back down here, now that it can actually build that part, there you go. You can see that it is moving again. And this reason it's moving again is because it built the next piece that it needs for it to move on. So the drill will keep going. You may require some management. You may consider again using something like the GOAT inventory management or Izzy's inventory management system. What the extra benefit of those are is that not just keeps the auto crafting going, but it'll manage your refinery and it'll manage your assemblers so that you don't get those inventory locks, which is so common. So that is the infinite drill. That will continue on and dig a hole through this tunnel, all the way through the mountain to wherever I need it to be. And I can just leave it running pretty confidently. Just maybe every once in a while checking up on it and seeing how it's doing. So thank you for watching. If you liked the video, hit a like. If you have any comments or questions, don't forget that you can leave a comment or question below and I'll try my best to answer them. If you have any other suggestions and you want to respectfully let me know, I am always eager to hear those. But for now, that's it for me. Thank you for watching. Stay safe out there. Be good out there. Have yourself a great day. Thanks for watching. Bye-bye.